This is Peter Diamandis, and welcome back to Exponential Wisdom with my dear friend and mentor and coach, Dan Sullivan. And Dan, I'd love to have this conversation be about something that has driven my life. It's been what has fueled the 8 and 9-year-old child inside me, which is space exploration. Because for the first time ever, we're reaching a time where entrepreneurs are building real businesses in space, and we're on the precipice of you and me and all our friends having a chance to actually participate in an extraordinary fashion. So commercial space, entrepreneurial space is finally here and real.
Peter, I was thinking as we were approaching this topic that probably there's an overview you can provide that would fill in a lot of blank spaces for people, because this has been happening largely in the private sector, so a lot of it isn't as known as it was when we were talking about entirely government-financed early exploration of space. So this is light years away from where we were in the 1960s.
Let me do this in two parts. I think one is, why is this happening now? And then second, who are some of the players out there that are the most exciting, at least from my mindset? So, we're hearing a lot about Jeff Bezos and Elon Musk and other companies, but why is this happening today, right now, in the 2016, 17, 18 timeframe? And I would say there's a number of factors. Number one, we have a lot of wealth being concentrated in the hands of individuals. Where an individual like Jeff Bezos and Elon Musk, both of whom I know very well, or Richard Branson or Paul Allen or Larry Page, all these individuals can say, I don't care if it economically doesn't make sense right now, I'm going to invest $100 million or $1 billion in this area. And that ability to deploy capital rapidly in a focused area without having to raise it or convince a Congress is game-changing. The second thing that's going on right now is material sciences. We have new materials that are stronger and lighter weight than ever before, more moldable, manipulatable, 3D printing of metal engines, and design of composite materials with new alloys and so forth. So material sciences is transforming it. Another element is the whole field of artificial intelligence and simulation. So the first time that SpaceX sent the Dragon capsule up to the space station, it worked perfectly and docked with the space station. And this would have never been possible before, except that they were able to simulate and have a real physics simulation hundreds, if not thousands of times before they ever went. So when it went to the space station, it performed exactly like the simulations had predicted. So that was amazing. So, gravity has not increased or gotten less. The laws of physics haven't changed. It's capital and technology that's put it in the hands of individuals. And so my quick overview now of who's out there doing cool stuff. Well, of course, Elon Musk and SpaceX, Gwen Shotwell, who's the president, Elon's the chairman, CEO, CTO of SpaceX. And I remember I met Elon back in, God knows, 2000. He had just sold PayPal to eBay, and he was committed to going into space. He was working on two projects. One, he wanted to send life to Mars. He wanted to send either a plant to the Martian surface, or he wanted to send a mouse around orbit around Mars. And when he investigated doing that, he realized that to buy a launch vehicle from Russia to do that was so expensive. It was ridiculous. And he said, there's a business opportunity here, right? Great entrepreneurs say, when you find a problem that doesn't make sense, you say, ding, 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 opportunity, and you create SpaceX. Zero background in aeronautics and astronautics, read the textbooks, put together the great team. And what he's done is effectively, I've tweeted this a couple of times, he's put a nail in the coffin of the traditional, industrial military complex, because the Falcon 9 vehicle now, and soon the Falcon Heavy, has got full reusability of the first stage, which has 9 engines, the most expensive part, and even the Dragon capsule. So that's SpaceX. They're fully committed to going to Mars. I had long conversations with Elon about the notion that that's the purpose of the company. By the way, one of the reasons he hasn't taken the company public is because he wants to be able to focus where the company goes and not have to worry about quarterly shareholder meetings or what the case might be, that the shareholders want to go someplace else and he wants to go to Mars. No, he's got control of that company. Jeff Bezos. Most people know about what Elon is doing. Jeff is equally a huge force in the space community. I met Jeff when he was at Princeton. I was at MIT. My first organization ever was an organization called SED, Students for the Exploration and Development of Space. Jeff ran the chapter at Princeton while I was running the chapter at MIT. He's been a space cadet since childhood. In fact, I remember when I met him, he said, yeah, I'm building Amazon so I can make enough money to go and open the space frontier. And that's been his business plan, incredible success, and he's committed billions and billions of dollars. And unlike Elon that wants to get to Mars, Jeff wants to move heavy industry into space and put millions of people into space. And he's got his fleet of launch vehicles are designing some of the biggest in the world to do that. And so I have huge faith in Jeff and Elon to effectively dematerialize and demonetize spaceflight by using the same vehicle over and over and over again versus throwing your vehicle away.
Can you just give us a very quick 60-second picture of what it means to have a recyclable rocket? Because it's quite extraordinary when you see it simulated. I've not seen the actual launch and coming back, but I've seen simulations of this and why it's so crucial, going back to the cost factor.
Yeah, sure. And I'll even give you the economics in detail because I've studied these and I know these. So since the first launch vehicle ever, since the launch of Sputnik to orbit back on October 4th, 1957, through the entire manned program for the majority of even the space shuttle, we'll talk about that as a separate case, the cost has been extraordinarily expensive because you throw away your launch vehicle. It's like flying from New York to London on a 747. At the end of that flight, throwing away your airplane, building another one for your return flight back. You imagine the cost per ticket would be literally $1 million instead of $1,000. It'd be 1,000-fold more expensive because you have to throw away your vehicle versus amortize many, many flights over that. So it turns out that, I'll use the space shuttle as an example for humans. The space shuttle program, even though it was partially reusable, was never really designed for rapid reusability. And the government space shuttle program cost $5 billion to run the space shuttle program, whether you launched 1 or 5 or 10 shuttles during a year. It was 20,000 people was the cost of the program. It was highly manual, highly difficult. And so if you did the calculations, the cost per minute was $100,000 a minute for an astronaut. It was a ridiculous amount of money. It turns out that you can, for a reusable vehicle, like a boat, a car, and a plane, you can do the economics that typically it's 3 times the cost of fuel. 3 times the cost of fuel would be the cost of, if you actually look at my airplane, all of that is roughly in a mature vehicle. And so the cost of fuel for a fully reusable Falcon 9 would be about $200,000. So about $600,000 would be the cost of a reusable, fully reusable vehicle. And since you have about 8 people on, you can imagine the cost per person coming down to less than $100,000 per flight for a person going to space. But it turns out you can do the energy. I'm going to take you back to your high school math here. Mass times gravity times height is your potential energy. 1/2 mv squared is your kinetic energy. And if you could buy the power off of the grid and convert that power into kinetic energy of being in Earth orbit, it turns out the cost of getting you and your spacesuit into orbit is like $120. So we have these massive price performance curves. And that's what commercial space is moving us down. I'll just mention very quickly my own company, Planetary Resources, which is going to be buying launches from Jeff and Elon to get to the asteroids, to mine those asteroids. You've got 5 teams working on the Google Lunar X Prize, building launch vehicles to get to the surface of the moon at a very low cost. You've got Richard Branson and George Whitesides with Virgin Galactic giving us suborbital flights. Who else am I missing out there? Paul Allen's got this large straddle launch airplane that's using an airplane for the first stage.
Yeah.
So a lot of amazing companies going on right now.
Yeah. Let's talk about mindset, because all breakthroughs require mindset. So one of the mindsets here is that you fundamentally have to change the position of energy on the planet to have the energy breakthrough for going into space, right?
Basically, the mindset changes that have had to occur for commercial space are a few very important ones. Number one is that because space began as a government program with the Soviet Union and the US racing, and then you saw the addition of India and China and Israel and Europe, not in that order, and Japan and so forth. It was very much a government-run program. And the mindset change that I've been working on with a slew of my co-conspirators from Greg Marinak and Bob Richards and Bob Weiss and many others has been to change the mindset that space is not just for governments, that it's for us as well. And the analogy I like and that I really am trying to push hard on is the early days of the European exploration of the New World. You know, the early days of the European exploration was the government explorers, but with a entrepreneurial bent. I mean, most people don't know, I'm sure you do, that Columbus had a sort of a commission structure, right? I think he got to keep like 10% of the proceeds of what his missions brought back. And ultimately, the other mindset is that space gives us a world of abundance, that everything we think of as scarce on Earth, metals, minerals, energy, real estate, are in near infinite quantities in space. And so I say and I believe the first trillionaires will be made as we open up the space frontier.
Yeah, talk about that, because people think of the planets, you know, they think of the moon as being the closest body and doesn't look to them like there's a lot of valuable stuff there, and then you go to Mars. But actually, when you talked about planetary resources, you were thinking about something that comes much, much closer to the planet that's available. Because I don't think people really comprehend what an asteroid is and what's on an asteroid.
Well, the dinosaurs comprehended what's on an asteroid for about a split microsecond before they burned up 65 million years ago. And so our universe began some 13.5, 14 billion years ago. Our solar system came into existence about 4.5 billion years ago. And out of this cloud of slowly rotating material condensed first the sun, and then these planets formed by local gravitational attraction. And a lot of the stuff, the formative stuff of our solar system that was left over, or as planets in the early days of these billiard game hit each other and got broken up or came into the gravitational tidal forces of Jupiter, there was a planet that didn't form between Mars and Jupiter that became the asteroid belt. Lots of bits of rock were left over. And so our solar system has tens of millions of rocks floating around, different size, from boulders to things a kilometer or 5 kilometers in size. And these rocks are asteroids, and when they hit the Earth, they become meteors when they're going through the atmosphere, and meteorites when they're on the ground. These are the three names of these objects: asteroids, meteors, meteorites. These rocks come in different flavors, depending upon if they were the core of a planet or whether they were the icy comet leftover parts of our solar system. And they're extremely valuable. These rocks are multi-trillion-dollar assets. And it turns out that a lot of these rocks are energetically hard to get to, but some of these rocks are very close energy-wise. Not necessarily distance-wise, but energy-wise. How much energy you have to put into your spacecraft in terms of what's known as kilometers or meters per second. It's a measure of the delta V, the change in velocity, and therefore the amount of energy you have to invest to get to these things. And so as my company that I've co-founded with Chris Lewicki, who is another coach member, and Chris loves coach. Chris is an amazing CEO. I serve as the co-executive chairman with Eric Anderson. Chris is the CEO. Chris has run 3 missions to the Martian surface, 2 before the age of 30, the third one at the age of 34. And we talk about going to these asteroids. We've identified, or Chris and his team has identified, about a dozen asteroids that are very energetically close to the Earth, that are large enough, that have got low enough spin rate that you could go to and actually land on and begin to prospect those and mine those asteroids for 3 things. The first is fuel, hydrogen and oxygen, or oxygen and methane. The fuel is very valuable and very prevalent on these asteroids. Some of these asteroids called carbonaceous chondrites are 20, 30, 40% ice, and that ice you can mine very easily. I mean, super simple. So simple a child could do it. I'll leave it at that. You would mine the water off of these and then break that water into hydrogen and oxygen. For rocket fuel, for fuel depots, by the way, every major space company, SpaceX, Blue Origin, Boeing, Lockheed, Launch Alliance, all want rocket fuel delivered to them in orbit. In-orbit refueling is the next future. That's what we're going after. These rocks also are rich in cobalt, iron, and nickel, which we can use for 3D printing with laser sintering. And then finally, some of these rocks, the metal chondrites, are rich in platinum group metals, 1,000 times richer in platinum, rubidium, osmium, palladium than the best mines on Earth. So the next gold rush is going to be in space.
Now, just to go back to the kickoff of this, and I think I know the progression of your mind to understanding that it was private, and that was your own desire to be an astronaut.
Yeah. I grew up in the 60s on the tail end of Apollo and during Star Trek, and it was interesting, right? Because Apollo showed us what humans could actually do right now. That was incredible, right? How gutsy. And how incredible and against the odds that in 1961, before NASA had ever launched a person to orbit, we were making a claim and we were going to execute on going to the moon. That was ballsy. We pulled it off. So Apollo showed what was possible, and then Star Trek showed where we were going to go. So there was this dynamic tension between today and the future. And as I got older and older and older, none of the future stuff was materializing, and NASA felt like it was going backwards. So I became enamored with doing this stuff myself in space, and I've started, of my 19 companies, probably 8 or 9 are space companies.
Talk about the community on the planet of skill sets, because I got to believe that there's whole new type of capabilities that are developing in preparation for this. And I have one question too, and it's the first 20 miles off the planet is the most difficult part of the entire trip. It's just that first gravitational barrier that you have to get through. And it's kind of interesting when people say once you're in space, things get real cheap real fast, but it's that first 20 miles.
Well, let's talk about that. Robert Heinlein used to say that once you're in orbit, you're halfway to anywhere. And it's true. So spaceflight is a matter of translating yourself, giving yourself enough energy from the surface of the Earth to get to a stable orbital velocity. And in miles per hour, it's 17,500 miles an hour. If you're going at that speed in a low Earth orbit, and we're talking about just 100 miles off the surface of the Earth, at that speed, you're in orbit. Centripetal acceleration equals gravitational pull, and you're balanced traveling around the orbit. Another way of saying it is you're shooting forward so fast that as you fall, you keep missing the Earth and missing the Earth and missing the Earth. And there are two mental models for thinking about being in orbit. It takes a lot of energy to get to Earth orbit. And the problem with it is, as you were alluding to, you can't add that energy slowly. You have to add that energy in a big concentrated push that gets you out of the atmosphere and into Earth orbit in the vacuum of space. And if you don't give enough energy, if you give 90% of the energy, then you're going to re-enter and come back and hit the planet's surface. So it's all or nothing. It's all or nothing. You're either suborbital or you get to orbit. And once you're in orbit, then you can slowly add energy and you can spiral out of Earth orbit slowly. You can use a solar sail. You can use the photonic pressure of the sun, or you can use an ion engine, or you can use any variations of rocket fuel to get you further and further out into space. So you're right, it is getting to Earth orbit that's the hard part. And then to get to what's called Earth escape velocity is about 1.41, the square root of 2 times your orbital velocity. So kind of roughly twofold gets you anywhere you need to go. So it's exciting, and I think what's most exciting is you're a history junkie, Dan. You love reading about the founding of nations and the early explorers. It's kind of hard right now to go someplace and start your own country. You need a lot of weapons to go and do that, and you have to trounce on native people to make that happen. So the beautiful thing about space is the ability to go and start our own colonies and maybe go start governments over again.
Yeah, and then, I mean, the one thing that's always interested me is the first human that's not born on the planet. That is really kind of a dividing line. There's like stage 1 and stage 2. And once you start having humans kind of look like us, but their framework for growing up is not Earth, and that's the beginning of an entirely new consciousness when you get to that point. And it will happen, certainly within your lifetime, mine.
I think the rate at which we're seeing progress commercially, we should see it within the next 20 years. I mean, Elon and Jeff Bezos are both committed to making us a multiplanetary species. As soon as I lasso an asteroid, and these asteroids are multi-trillion-dollar assets, I think you'll see me. I have 3 major passions in life. One is opening up space, the other one is longevity, and the third is sort of inspiring entrepreneurs to solve grand challenges. And I'll use that capital to open up space. I can call him my friend, Stephen Hawking, who I had a chance to fly into 0G on our parabolic airplane, is very passionate about space for the reason that he wants to take all the eggs out of the basket of Earth. He says, we're precariously positioned from a whole number of reasons. Another asteroid impact, nuclear war, and so forth, to wipe ourselves out. But once we become a multiplanetary species, we're much more robust. You've backed up the biosphere, so to speak.
Well, it's interesting. I had never told you this before the presentation, but I got hooked on the PrePre Space period, and it was right when I went through the transition from propeller-driven planes to jets. And then the early rockets, the Douglas Sky Rocket, the Bell X-1, a lot of those test pilots actually became certainly the early candidates for being astronauts.
And the Mercury 7.
Yeah, the Mercury 7. And those were very exciting days. I can remember the first time, the sound barrier was broken fairly early in the 40s, but you got to 2 times the sound barrier, you got 3 times the sound barrier. I think the Bell X-1 got up to about 3,000 miles an hour. One of them did. And there was this enormous excitement in the 50s of where this was going. But to a certain extent, it took a contest, and the contest was between 2 big political systems to actually do it. So this is like a third way that we're creating here. And there's a lot of competition, I'm sure, among the billionaires about this, but there's probably an enormous amount of cooperation too, because they built their entire fortunes on cooperation. And I would suspect that they're lightweight in terms of staff that they need to actually put up a rocket. It's just a minuscule number of people compared with NASA.
Yeah, well, governments do this for public works, employing as many people as possible. Jeff and Elon are trying to build autonomous systems that are fully reusable, so it brings the cost down. Interestingly enough, what I find extremely exciting is Elon has set a ridiculously low price target for getting humans on a round-trip ticket to Mars. $200,000. I mean, so for the price that Virgin Galactic is sending you on a suborbital hop, Elon wants to take you to Mars. And I think he's right about this, because ultimately, if he wants to create a business that is of massive scale, taking hundreds of thousands of people to Mars to create a 1 million-person population there, so you have enough genetic diversity and you have enough people who care about Mars, the price has got to come down. So that it's the next generation of homesteading, right? This is the early Europeans moving to the Americas, or the American settlers moving to the West. And his interplanetary exploration vehicle is the covered wagon that people can afford.
I was just thinking about the previous episode where you talked about your twins, and this is going to all seem very normal to them. This won't seem unusual.
It's interesting because the Apollo program, the space program, was normal to me growing up. Not going to the moon became strange after a while. And the political whims that drove that, I'm very clear that programs built upon governmental races or governmental whims are, like, say, a start, stop, cancel, because a new administration comes in and they have different priorities, things change. But if you're able to build your opening of the space frontier based on commercial drivers.
Yes.
Like, mining asteroids for precious metals and fuels, or getting people to Mars to homestead it, who are willing to pay in large volume $200,000 a ticket, then you're independent of the government and you're doing, like everything else, you're building a real business.
One last observation, this would be a historical context one. If you look at the almost diametrically opposite development of South America and North America when they were the New World, the whole Southern and Central American one was done through government mandate from Spain and Portugal. Things were imposed. And for the most part, the North American continent, as far as Europeans was concerned, was done through private stock companies. And the Jamestown Company was the first permanent. It was privately funded. The Hudson Bay Company, which has been operating in Canada since 1670.
Amazing.
Was all done through private funding. And the British, when you look at the creation of Canada, the United States, really did it on the cheap because they just got people who they would give them grants to go over and look, whatever you find, you can build it and you can own the property. Probably another whole episode down, but the importance of private ownership in space, because without private ownership, it isn't going to happen. That's for another thing. But if you look at where North America is now compared with most of South America, the private approach really proved to be far superior.
Agreed. I'll also tee up another difference. I just came back from Brazil, and another podcast would be about the willingness to fail, right? The willingness to take risk. One of the things I learned as I was down talking to entrepreneurs, if you build a company and you fail, that's it, game over for you. Where here in the United States, if you fail, we call it experience. So that the difference of that and how that drives entrepreneurial energies, I think, is an important conversational subject.
Yep. Well, I consider them merit badges, and I have 2 bankruptcies on my record, and I haven't neglected the lessons that I got from my 2 bankruptcies. I just call it extreme market research.
Val, as always, a pleasure. Thanks for letting me wax on about my passions of space. And
there's a lot of wide-eared and wide-eyed people out there listening to this one because, one, nobody has really been thinking that this was even feasible, but how close it is in terms of your own inside knowledge of how close we are to this becoming a practical reality. Within the next decade, major breakthroughs will be made. So
right now, anybody who wants, you can go and do a parabolic zero-G flight. The website is 𝐂𝐒𝐄𝐒.com, 𝐂𝐂𝐒𝐄𝐒.com. It's about $5,000. I've had the chance to fly over 100 times, flown Stephen Hawking, flown with kids age 7 to the oldest 93. It's an amazing magic show. So you do that. You can go and buy a suborbital ticket on Virgin Galactic. I think it's $200K or $250K. I'm blanking on the price at the moment. And then there will be orbital flights on SpaceX. On my other company, Space Adventures, takes people to the space station on the Russian Soyuz. That's expensive. It's $50 million a shot today.
But for a more immediate mind-shifting experience, they can pay $12,500 and come to A360 in the first week of January 2018. They'll get their mind's worth of new insights. So we're right in the ramp-up now for filling up the last seats for A360. And
yeah, it's been amazing. We'll talk about that maybe next time, the value of a 25-year commitment.
Yep.
When you make a commitment for 25 years, you're sort of like throwing yourself, you're imagining what it's going to be like 25 years from now, and you're imagining the unimaginable connected to the web.
Well, you also notice that there's enough inside you that is fascinated with the idea that you can be totally confident that you can stay with it. I think that's one of the big things.
Yeah. Anyway, a pleasure, pal. See you next time, and thanks to everybody listening to Exponential Wisdom.
Peter, always a pleasure.